Okay, in this session, we are going to discuss about the multiple choice questions of hydroxy compounds, right? Hydroxy compounds are basically alcohols. So, as in this question, they are saying four different alcohols are treated with alkaline I2 aqueous solution. Actually, this is also known as iodoform test. Clear? So aqueous I2 and alkaline means treating these alcohols with aqueous iodine in presence of sodium hydroxide. So for these type of reactions, remember one thing when we talk about alcohols, only ethanol is the primary alcohol which gives iodoform test. Other primary alcohols, they do not give this iodoform test. For example, CH3, CH2, and OH. The carbon with which OH group is attached, that is our alpha carbon, and the next one is the beta carbon. So in its mechanism, what happens? This methyl group, which is attached with the alpha carbon, that will give us iodoform, right? For example, CH3, CH2, and OH. So in this will give us CHI3, which is known as iodoform. And the rest of the molecule will give us an acid, which is only one carbon left. So it will be HCOO negative. And as we know, there is an alkali, so it will be a salt. And the other product is sodium iodide and water. Is it clear? So iodoform will only be given by in primary alcohols by ethanol, which has methyl group attached with alpha carbon. Similarly, secondary alcohols, those secondary alcohols which have small methyl group attached with the alpha carbon, they will give us iodoform test. For example, if I have this secondary alcohol. So as I know, that is my alpha carbon with which OH group is attached. So it is attached with, on both sides, have beta carbons, means methyl groups. So it will also give us iodoform test. This will give iodoform, and the rest will be the acid of two carbon atoms, CH3COO and Na. So let's and remember one thing, that tertiary alcohols, they do not give iodoform test. So let's see these options. Option A, it is butane 2-ol. So 1, 2, 3, 4, and OH. Yes, we can see it's alpha carbon here, and there is a methyl attached with it. So it can give iodoform test. So what products we will get? This will give us CHI3, and the rest will be the acid of three carbon atoms. So it will be CH3, CH2, and COO negative, and then Na. So in option A, they are saying CH3, CI3. No, it's incorrect. Okay, let's see option B, propane 1-ol. So 1, 2, 3, and so it's primary alcohol, as we know, alpha carbon bonded with one beta carbon. So that is not giving us iodoform test, because as I said, primary alcohols only ethanol will give us iodoform test. Okay, propane 2-ol. So 1, 2, 3, and OH. So this is our alpha carbon bonded with two methyl groups. So any one of them can give us iodoform. Yes, it will give us CHI3, and the rest will be the acid of two carbon atoms. So CH3, C double bond O and O negative. So will be in the form of a salt along with, so let's see options. It is giving us CHI3. Yes. It is giving us ethanoetine. Yes. So option C is correct. But what about D? They are saying butan 2-ol. So if it is butan 2-ol, yes, it will give us iodoform test, but the acid will be of three carbon atoms. On oxidation, it will give us acid of three carbon atom. So they are saying CH3I. No, it's incorrect. Iodoform formula is CHI3, not CH3I. It is iodomethane, and iodoform is triiodomethane, CHI3, which is giving us yellow precipitates. So it's a test to identify between primary alcohol and secondary alcohols, which have methyl group attached with the alpha carbon. And remember, tertiary alcohols do not give this iodoform test. So in this way, we can identify the correct answer. Is it clear? Okay, in this question, they are saying compound X is heated under reflux with excess of acidified potassium dichromate 6, which is a oxidizing agent, right? Okay, so as we can see, option A, B, and C, I have drawn their structure. So on oxidation, what we can see here in these examples, this one is secondary alcohol. So when it undergoes oxidation, that will definitely give us ketone, C double bond O and CH3. This one is tertiary, right? So it will also give us, no, it will not oxidize, right? This one is secondary, that will also give us ketone, right? And this option D, that on oxidation, it is primary, as we can see here. So it will give us aldehyde, right? C double bond O and H. And on further oxidation, this aldehyde will give us carboxylic acid, as you can see here, right? So this carboxylic acid, that is our compound Y. So here we are seeing the compound Y in all these three options. Two of them are ketone, while the third one, that is carboxylic acid. And they are saying compound Y reacts with X under suitable conditions to produce compound Z. As we know that our X is an alcohol from these examples. So we know that alcohols, they react with the acids under suitable conditions and gives us ester. So we know this option A, that is producing ketone. So ketones do not give acidification reaction with the alcohol. So it will not be A, it will not be the option C, and this one is an acid. So it can react with the compound X and it will give us an ester. And if we perform its reaction, so it will be CH3, 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 C double bond O, and O, that will give ester along with the compound this X. So it will be CH2, C, CH3, CH3, and CH3. So when we calculate their molecular mass, so the answer will be 172. So it's option D. That is the correct answer. In this question, they are saying in which reaction the organic compound is oxidized. So in option A, they are saying tolerance reagent. As we know, tolerance reagent is ammonical silver nitrate. So silver ions are there in ammonical silver nitrate, which is known as tolerance reagent. So when they react with the aldehydes, so they give us silver mirror. As we can see that silver is gone from +1 oxidation state to 0. It means the silver is reduced and it oxidize aldehydes into carboxylic acid. So CH3, CH2, CH2, C double bond O and O. Carboxylate ion will produce. So this aldehyde will oxidize in this reaction and we will get a silver mirror solid. So yes, in option A, this organic compound that is oxidized. In case of option B, you can see it is lithium aluminium hydride, which is reducing agent, right? And a reducing agent will reduce this aldehyde to alcohols. In option C, it's concentrated phosphoric acid. So, as we have seen the reactions of these alcohols, that will give us elimination reaction, and alkene will produce. In this case, we have seen it's an ester when reacts with dilute sulfuric acid. So, it will give us hydrolysis and it will give us carboxylic acid, right? And an alcohol, right? So, in option A, the organic compound that is oxidized, right? They are saying the reaction which will distinguish between the primary alcohol, alpha carbon, and beta carbon. Here it's secondary propan-2-ol. They're saying option A, warming with acidified KMnO4. As we know, it is oxidizing agent, and the primary alcohol will oxidize to aldehyde, and this secondary alcohol that will oxidize to ketone, right? Okay, so both oxidized, and the color of KMnO4 that will goes from purple to colorless. It means option A is not suitable to distinguish between these two. Both will give reaction with KMnO4, which is oxidizing agent. So warming with acidified potassium dichromate. So this one is again oxidizing agent. And as we have seen that both undergo oxidation, primary alcohol gives uh, aldehyde, right? And secondary alcohol gives ketone. So the color of potassium dichromate that will also change from orange to green. So this test is not suitable to distinguish between primary and secondary. Now, option C, they are saying dehydration. So if we take, let's say, propan-1-ol. So on dehydration, what will happen? You can see the alpha carbon will lose OH and the beta carbon that will lose hydrogen, and we get propene, and followed by a reaction with Br2. So if Br2 reacts with it, so that will give us definitely 1,2-dibromopropane. Is it clear? So let's see if we have this secondary alcohol. So there are two options, same on both sides. So on dehydration, that will again give us propene. And when it reacts with Br2, so in both options, we will get same product, 1,2-dibromo propane. So the color of Br2, that will goes to colorless in both the options. So it means that will not give us a clear indication between these two primary and secondary alcohols. So let's see mild oxidation. Okay, yes, if they undergo oxidation, so one of them is giving us aldehyde, right? And the another one that is giving us ketone. Okay, and followed by the reaction with Falling's reagent. As we know that Falling's reagent is the reagent which give a test for aldehydes, but ketones, they do not give a clear indication test with Falling reagent. So the color change in or precipitates in Falling reagent, red color precipitates, they are given by the aldehyde, while ketones, they do not give this Falling's reagent test. So yes, option D is correct in this case. So that's how we can differentiate between primary alcohol and secondary alcohol. Clear? In this question, they are saying compound X can be oxidized to compound Y. So first of all, option A, it's butan-1-ol. As we know, it's primary alcohol. So when it undergoes oxidation, so that will give us aldehyde. Let's see, CH2, CH2, oh sorry, C double bond O and H. C double bond O and H. And remember, they are saying compound Y gives yellow precipitate with alkaline I2 aqueous. That is actually iodoform test. So in case of aldehydes, so you have to remember that only ethanol, that is the aldehyde which gives iodoform test. Why? Because you can see there is a methyl group attached with carbonyl group, right? Only ethanol gives iodoform test. So as we can see here, if it gives uh, this butanol, so that will not give yellow precipitate with aqueous I2. So option A is incorrect. Here we have seen it's a secondary alcohol, so on oxidation, that will give us, you can see, ketone. And for ketones, remember, small methyl ketones will give iodoform test. Small methyl ketones. What does that mean? That this carbonyl group, if it is bonded with any one or on both sides, the methyl group, then that will give the iodoform test. So yes, butan-2-ol on oxidation giving us a ketone, and it is a methyl ketone. So that will give an iodoform test. CHI3 will be produced, and the rest will be the acid of 3 carbon atoms. So you can see carboxylate ion will produce. Yes, option B is correct. Methyl propane 1-ol. So it is again primary alcohol. So on oxidation, that will give us aldehyde. And as we can see, the aldehyde produced will be not an ethanol. So option C is incorrect. Option D, it's a tertiary alcohol, and tertiary alcohols, they do not give oxidation reaction. They are saying oxidized to compound Y. So that's why option D is incorrect. So that's how we can find out the correct answer.